This is a 1/4 inch drive, 1/4 inch socket. I got the deep well for just a little bit extra range. It was like $2, maybe $3. This is a motor. I actually had it laying around, but I did order it off Amazon. It's just it's a low RPM, high torque, 12 volt motor. So I'm going to stick this inside the socket, because inside the socket there's a hole. So I'm going to stick this in there. That way I can put hot glue as a little bit of a base. And then I'm going to use JB Weld on top of that. So now you can't see the hole. Alright, so I put that in there, so now you can't see through it. I'm going to put a little bit of hot glue in there just to cover the bottom. I'm going to go slow because I don't really want it to touch the sides. It might mess with the JB Weld. Well, that didn't work as well as I wanted. So I'm going to try to make a little template to do this as professionally as I can. Looks like it's going to be that one there. So it looks like 7/16 is the size. So I'm going to use a 7/16 hole on this stencil and then try to get an actual center. Or it's going to be a little bit off. Okay, that looks a lot better. I can cut off little tabs and put those on the outside. That way I can kind of line it up a little better. Alright, so I'm going to cut it out with a X-Acto knife. Like, I'm left-handed, so hopefully you guys can see something here. Doesn't have to be super perfect, because all you're trying to do is get this lined up on the center, and then you're gonna like tape it in place. That way when you put in the motor, it won't move. So this is kind of like, it's going to be kind of like a stencil in a way, or a template, or whatever you want to call it. Not very good at X-Acto knifing stuff, but oh wow, that came out a lot easier than I thought. Probably should have done this hole first, and in fact, if you're watching this, I would recommend doing this hole first. That way you don't have to try to hold this tiny piece of paper like I'm doing right now. Work smarter, not harder. Okay, so that works pretty well. Hopefully my camera is not too bad on showing that. I'm going to fill it with JB Weld, hopefully, and then stick the motor in over the template on the top, and then just let it sit. So we'll see how that all goes. Alright, so the next step is filling this with JB Weld. Once you get JB Weld going, you need to work pretty quick, because it does harden fairly quickly, but more importantly, I'm going to need it kind of in a liquidy state. That way it can actually flow into this area, this hole. So I'm going to mix a little more than I normally would for a project like this, because I need it kind of like runny, if you will. And then, so after I fill this with JB Weld, I have my tape ready, You have to have tape ready, that way, like I said, it kind of goes kind of quick. Get the JB Weld in there, just probably up to the little bezel there, and then put the template on, tape it, drop the motor in, and then I'm just going to leave it sit and let gravity do its thing. I do have a artsy popsicle stick here that I cut down to the width a little smaller than this, that way I can actually spoon it in there. And the JB Weld I have is just regular kind of like multi-purpose JB Weld. It's the one that's for pretty much everything. So it doesn't really matter as long as you get one meant for like metal, I guess, since we're working with metal. And then with JB Weld, the instructions are on there, but you're going to mix half of what you think you'll need, because there's 2 parts. So if you do half of what you think you'll need, you'll come out with one whole part when it's done. And then you're going to mix it together until it's one gray color, or whatever color they both mix into. This is going to be kind of gray. And then I'm just going to spoon it into the socket here. Trying not to get it on the outside, but oh, that's not going to happen. Now, I think this might do it for me. I'm going to put the stencil on, then I'm going to tape it. I'm out of electrical tape, so I'm just going to be using a clear packing tape. So the tape doesn't actually want to stick, so I'm just going to hold it and then drop in the motor. I think I put on a little bit too much hot glue, so I guess I'm going to have to hold it. So here's the finished project. I skipped it a little bit and I didn't film me soldering the board just because it's kind of redundant. So here's the circuit board. I have velcroed the 2 9-volt batteries, and I'll explain that later, to the bottom of the circuit board. I also put a layer of hot glue on the bottom of the circuit board to protect the wiring, just so I don't short something out. I hot glued the motor to the board, and I actually put one of those little double-sided sticky pads in between. Put some tape so I didn't short circuit any of the contacts over there. Hot glued the rest of the motor. This will work for version 1. All I have on this motherboard is 2 relays and 2 button switches. And you have a forward and you have a reverse. It's a 1/4 inch bit. Or sorry, it's a 1/4 inch socket. It's a 1/4 inch drive, 1/4 inch socket. So what that means is these regular 1/4 inch bits, flathead, Phillips, Torx, whatever, fit right inside. It's not magnetic, but you can make it magnetic. So I made this to be small and useful just with circuit boards. You can use it for other things, probably smaller applications. I really don't know how big or tight of a bolt this can move, but I just made it for circuit boards. As you can tell, it's a little bit lopsided as far as it's spinning, but I'll correct that on version 2, and I am going to make another one, version 2, just with some things I want to do differently. And I'll explain how I did the circuit board. So a relay is basically a switch. So the relays I'm using, I will draw those how they actually are. So these are actually how my relays work. So these have 5 pins. Most mechanical relays will have 5 pins. Solid state, some of them have 4. I think maybe all of them have 4, but either way. This right here is called your coil. I'm left-handed, so I kind of have to work with this here. This is your coil. This is kind of a standalone thing. Depending on your relay, it'll operate within its own voltage. This might be rated for 3 or 5, 8 or 12 or whatever, while the other, half of the relay is operated at a higher voltage. So let's just say this coil is closed with 12 volts. So you have your positive and you have your negative, and then that goes to 12 volts, and then this one goes to ground. This would basically be your battery. And that's all you do for that. Then these two over here on a typical setup would be like that one would be nothing or ground, and then let's just say that's ground or nothing, so or nothing. You could also have something there, but let's just go with that, ground or nothing. And usually the other side is going to be something. So let's just say this is rated for up to 34 volts. So let's just say this is a 12 volt input, and then you have it grounded somewhere else. Your relay right down here, this is basically a switch. These two contacts with this little arm in the middle is going to be a switch. So this is going to be normally closed how it's drawn. It's going to be drawn in the de-energized position. So it'll be up against this contact here, which will be ground or nothing. That's when the relay is de-energized. Now when up here you energize this coil, this little arm will move over to the normally open side. When it's energized, it'll switch over here, and this will be now closed, but when the relay is in the de-energized position, that's the normally open side. So anyway, you energize the coil, this switches over, so now 12 volts or something is now running through here, through the little arm, and then over to this pin. So this pin goes out to whatever needs 12 volts. Hopefully this makes sense so far. I'm probably not the best explainer about this stuff. Now, how my board works is something I kind of thought of by myself. I'm not the only one, I'm sure, and you can do this in other ways, but I like to do it this way because I don't need a microchip or a microcontroller or anything like that. So I have 2 relays. So let's just say one relay is going to be up and one relay is going to be down, or left and right, depending on what you're using or how you're using it. So you have the coil. I'm just going to draw it like I drew the other one because that's actually how mine are set up on this board. So that's your really poorly drawn coil, and then that goes over here. So these are both drawn in the de-energized position, and they're also the normally, the little arm is on the normally closed side. That means when it's off, this is resting against this pin making contact. So what I did for the board is I'm still operating the coil like you normally would. This is a 12 volt relay. I'm operating it with 9 volts. 9 volts. It's a 12 volt relay and a 12 volt coil. That's how much voltage is maximum for closing the coil. You can do it with a lower voltage, but here's the thing. In my relay, this coil, the resistance in it is 300 ohms. When you try to close this coil with a 9-volt battery, you're no longer closing it with a 9-volt battery, you're closing it with something 300 ohms less than a 9-volt battery. So when you try to power a 12-volt something with the other half of the relay, with the same power source as the battery with the battery closing the contacts, it's not going to be strong enough. That's why I have 2 batteries. So one battery controls both contacts on, or both coils on the relay. So let's go with this. Same battery. Yeah, hopefully this all makes sense. Okay, so now the wire is going to the positive and the negative. I have a switch on 1. So hopefully you guys can stay with me here. So how I did it is you have the coil here. This one's going to ground of the battery. This one's going to a switch. And then the positive of the battery. So that's how these are set up. Now the other 9-volt battery I have coming into here. So this is the same 9-volt battery. The normally closed contact of both relays are going to be ground, or let's go with negative. Sorry, let's go with negative. Okay. On both relays, the normally closed side are negative to the 9-volt battery. So that's going to come down here, and that's going to come down here. Let's draw a box for the battery. Now, the normally open side of both relays are going to be positive of the same battery. This is kind of a backwards setup for a relay. Kind of. It doesn't really matter. But if you know anything about relays, you're probably thinking, wow, this is kind of backwards. Then this pin up here is going to be your output of your 9 volts. The way why I did it this way Alright, so why I did it this way, and let me zoom in just a hair so you can see a little bit better, is when you close the contacts of this, you close the coil on the right relay. This energizes, kicks over to the positive 9 volts, and then shoots it out the top. So now you have a positive 9 volts, while on this side you have a negative. So this is going to the motor. That's a motor. So you have positive and you have negative. So when you apply positive to this side of the motor and the negative's coming out through the relay, through the normally closed contacts, and out to the negative. So it completes the circuit, allowing the motor to spin in one direction. Now, when you close the coil on this one, it goes back to negative. Now the motor stops. When you open, it goes back to the negative. They're both sitting at negative. Motor does nothing. When you close the contacts on this relay, it switches over to the positive. Now this is giving out positive 9 volts to the negative side, and coming out the positive side of the motor to the other relay, which is normally closed now because it's off, is now negative. So if you follow me, you would have the motor spinning in the reverse of what it just was. So now with these two relays, you have a forward voltage and a reverse voltage without doing any microchips, microcontrollers, transistors, or anything of the sort. You're just using 2 relays and 2 button switches. So if that all made sense and you followed me, that is what I did. That's why I have 2 9-volt batteries, simply because the coil takes too much resistance away from everything else. So one battery is only powering the motor, one battery is only powering the relays. That's why you have one button goes to the right and the left button goes to the left. I didn't actually intend for this to happen. Right is going right and left is going left. I just wired it up that way and I found that out later. I'm like, oh, it's actually going the right direction. So keep that in mind if you make it. That's pretty helpful. That's also why you hear that click. That's the relay, that's not the switch. So now you have reverse and forward voltage with just using relays. And I made all of this with just stuff laying around. So if you are tech savvy and you have stuff laying around, go ahead and make one. I will be making version 2 and making a video of that. Hope this all made sense. Hope you liked it.